Hello, welcome to Econometrics Melody. In this tutorial, we'll deal with two-way spike, two-way rspike, two-way pcspike, and two-way PCI types. So let us prepare our data set. We have a long list of data this time. And our first plot type is a spike, two-way spike plot. And this will draw a spike plot. And it is obvious or evident by this graph, we get a spike plot. Difference variable, symbol number, ESCN, symbol number. The last variable it acts as the x variable, and nth variable that precedes the last variable acts as the y variable. And this difference variable is the difference of export. It is the first difference of the export. Now let us move to another option. We have a specified vertical. This is not going to change the look of the graph, but if we specify the vertical horizontal option, then we get the horizontal spikes. Let us combine them all and see how does it work. Holes 3, this will leave the third block empty after combination. So 1 2, this is the third block, so this is empty due to this option called holes 3. Now let us drop them all. This is a simple graph. So specifying vertical does not change the look of the spike graph. And here are some of the options, very easy options. Vertical and horizontal we have seen already. Base, line option, axis, twice options, and two-way options. These are very simple options. Now let us see another example. We are going to draw a line plot type of expenditure, export, and symbol number. And then a spike plot also. We have combination of line and spike. So this is a spike of difference and symbol number. So our x variable is symbol number, and we're going to draw the export and its first difference. The upper part, this line graph, is the hypothetical data of export, and this spike graph is its first difference. So now let us try to get the same result by making use of line plot and drop line plot. So drop line, we are going to get same result and a rather beautiful result. We can combine this. So the result of this spike plot can be attained by this drop line as well. Now let us label this the second graph or the latter graph, the spike graph, its y-axis into the alternate axis. Let us use the alternate y-axis to label the spike y-axis. So we have reinforced the yscale of this range for axis 1, the main y-axis, yscale of this range for alternate axis, alternate y-axis, and then we draw a y line so it access to this will be evident by, for example, by the graph. So here this is the main y-axis, this is the alternate y-axis, and we have asked Stata to plot the line plot in line plot, and the y-axis will be labeled a first axis, and the spike, the plot of spike or the spike plot, the difference and symbol number. So the y value of this will be plotted in the y alternate axis. This is the result, and we have yscale. So we have the difference of 0, the positioning of 0 is different because of this difference in range. Had we specified the same range, 0 for main y-axis and the 0 for alternate y-axis would coincide. Now let us combine these two, and again we have holes 3, so the third block will be empty, and we will see the difference. So holes 3, there are actually only two plots, so G1 and G3, so this does not affect in any way. Now let us drop all of the graphs that we don't need. This is all about two-way spike plot. Now let us move to the So did we complete it? Yes, we completed it to be a spike plot. These are very simple. Now let's move to rspike. Rspike, R stands for range, and we are going to combine two connected graph, two connected plot type. The first one high and close, the second one low and close, and let us say it is a connected graph. And similarly, we are going to recall, or we are going to derive the similar result by writing R connected and then specifying high, low, and close variables. Close is our x variable, and these two are the respective range variables. So we get the same result. Similarly, we are going to derive the similar result by using dot plot and making use of the difference in size of the dots and so on. So we have combined two dot plots for high close, low close, and we're getting a similar result. Finally, rspike. Let us draw the similar result, and this will draw the spikes. So high and low will be joined by the spikes. These are the spikes. And if we combine them together, so all the four graphs, they represent the same information. So this graph is the result of combining two connected plots. The result of this graph is the result of using one R connected. We specify three variables for range plot types. Here we got this result by using combine two dot plot types, and this again this is a range plot type, so we specify three variables, high and low, and this x variable. So from different plot types we can get similar kind of result. There are a lot of options to choose from. Stata has provided us this option, and for the option of this plot or spike plot, we have these options. These are very simple options: vertical, horizontal, we have seen about it, line options, axis options, and two-way options. Now let us see some of them. By the help of example, we are going to use two plot types, rspike and line, and we see this difference. So the red color are the spikes representing high and low, and the khaki color that represents a line. That's a simple one. And let us see, here we are using three plot types, rspike, line, and bar. We are combining it with this binding operator, and we have added to the above graph, we have added the bar graph representing the volume of the volume. So this represents the volume. Now we can also use the alternate y-axis to label this bar graph, and in the second example we are making use of this, and we declare this, so yscale for the main y-axis. This is the scale for alternate y-axis, and the y-axis second we have drawn bar, this chart or plot type on the alternate y-axis, so the y value will be represented in the alternate y-axis, and these are the manipulations which are easy, very simple. Now here we see this labeling on the bar chart, 0 for this alternate y-axis, and the 0 for main y-axis is way down. Now let us combine them all and see it. So here we have not specified holes, so the graphs will be plotted in sequence 1, 2, 3. So had we specified here holes, let's say the third, so the third block will be empty. I will get the graph on first, second, and fourth block. And sometimes we may want to draw the graph according to certain categories, and we specify by option, and it may not work all the time. So here we want to draw the same graph by according to the countries, and let us see we are able to get the results or not, and we are not getting the desired result. So this is not our required result. So in that case we can always use this option, if option, and let us see what are the countries. Actually there are two countries, Nepal and Japan, representing equal number of observations. So we can use if condition. We can plot it for the first country. If country is equals to 0, so we have specified this condition over here. If country is equals to 0, this represents one country for Nepal, and we can draw the similar graph for another country, Japan, if country is equals to 1. So if country is equals to 1, the same graph will be repeated for country 1, and we can combine them together and see the effect. Again, we have not specified holes, so the graph will be plotted in the sequentially. Country, this is the total result without distinction of the countries. In here, this graph is for the country Nepal, and this graph is for country Japan. Now let us drop them all and quickly move to another plot type. It is pair coordinated plot type, and by the name it is evident that we need pair of coordinates, 2 points actually. So first point represented by y1x1 and second point represented by y2x2. And if we use pcspike, we'll get a line. Actually, we'll get a spike joining these points. 12, 10, 1 point, and 24, 25, another point. So these are the extreme points, and this is the spike plot. Similarly, we can combine the spike plot with scatter or other plot types. Now we are going to add some marker to the end point y1x1, and we want to identify which is the initial point of this spike. So this is the initial point. Similarly, we can add another point, another scatter by the help of another scatter plot. We are going to add another extreme point, some marker. Previous the initial point was represented by triangle. Now the end point is going to be represented by the circle, and it will be labeled by the GDP, variable GDP, and it represents, so this is the GDP of country DDD. So initially it is started at this point, and its GDP declined over the period, and so on. Now let us combine them together and see it for ourselves. So it gives a clear picture of starting point to ending point if our data carries that meaning. So the initial point, these are the starting points, and the ending point, these are the represent certain time elapse. Ending points. Now let us move to another example. So let us drop y1, x1, y2, x2 and create new variables. We have a list of variables over here, and we're going to draw a network diagram, and let us see how does it work. So we make use of pcspike, y1, x1, y2, x2. So they are constructed in such a way that they form a network. So ending to beginning, and this point should serve is the ending point of this spike should serve as the beginning point for this spike. And we have intentionally drawn this kind of created this kind of variable. And again, now let us, by the help of a scatter plot, let us add some markers to the starting, ending, and the in-between points, and we have provided label as well. So these three scatter points, they are going to help, they are used to draw the markers for these starting, ending, and middle points or joining points. All the features are similar. M size, it represents the size of the marker, level position, level first. So we have used this variable called first to label the marker for this, and second is scatter, maybe this is the middle one, and it is evident by the color blue. And this third is scatter. This plot actually it helps in creating the green marker for the endpoint. Now let us move to another plot type. It is two-way paired coordinate plot, PCI, pair coordinated, and I stands for immediate argument. So we don't need to refer the variable name, so we can input the data and get the result instantly. So to a PCI, we're going to get pair coordinated graph out of it, and we get this spike pair coordinated, and the label is not displayed. So in order to display the label, we'll have to plot this pair coordinated these points and recall or recast it for the another plot type. So we have recasted here. It's a PC scatter, pair coordinated scatter, and this should be able to take the labels, but as it is a scatter plot, we don't expect it to join the endpoints y1 x1 and y2 x2. And let us again try some other variation, and we have recasted it as PC scatter, and M symbol we have used triangle for a marker size 3 and so on. Label position, so we have played around with marker symbol and label position. And if we specify the option called label head, rest of the styles and options are same, but if we specify the label head, head label, the second y2 x2 variable will be labeled. By default, y1 x1 variable are labeled. Now these labels will sit to the point, and if we combine them together, we will see the difference. These are very simple. Similarly, if we recast it as pcspike, and we will also explore about this plot type in our coming videos, and let us see what happens if we recast it as pcspike. This should be also, or this should also provide the labels. And actually we have forced the M symbol to be as a triangle, that is why we get a triangle. Marker size, marker color green, marker level position, and other options are simple. Now let us recast this as PC arrow. We are also going to, in our following upcoming videos, we will explore about PC arrow as well. This will simply draw the arrow diagram, and we have the arrow over here, and if we want to have arrows at the both ends, we should specify PC by arrow. So here PC, B stands for by arrow or both arrow for our understanding, and just other things are same. Head label, that so once we specify head label, y2 x2 variables are labeled, or y2 x2 point is labeled. Now let us use PCI. We can try so PCI can be used to plot the points. It's for our requirement in any graphs. Now we are going to make use of function. We'll also explore this plot type in our coming videos. So here we are going to draw the upper part of the circle by this first option, and or by this first function, and by the second function we are going to add the lower part of the circle. And PCI, we are going to use this to draw the line, and we are going to actually draw the circle having origin at the center. So function is contributing to draw the circle, and PCI, the for PCI is going to contribute in this, placing the center point, drawing the axes, and this is vector. And let us again see another example. It is an example. This may not be useful for our analysis, or so this example is to help us to reinforce the understanding of PCI. So we are going to this line at respective position, x equals to 2, x equals to 3, y equals to 2, y equals to 4, and by the help of this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, we are going to draw 14 markers by the help of this scatter eye, and we will get this result. So here are two markers, actually two scatter plots, the small one and the bigger one. So 5 to 10, and this cross 11, 12, 13, 14. Overall 14 scatter eye has been used. So I is for immediate. So we need not require the data in the memory. We can plot it on our own by a simple input. So this is very useful. And let us drop all the graphs that we have drawn. This is the time to thank you all for your precious time. Thank you very much, Econometrics Melody.